We're going to show you how to provision hundreds or thousands of custom IoT hardware devices onto your fleet using Golioth, certificates, and some simple examples.
So what we're using today as a target is this Thingy91, which is a Nordic product, but we like it for this demonstration because it's basically a piece of consumer electronics. So when your company is producing something like this and it's rolling off the assembly line, how do you get credentials onto it and make sure that it's added to your IoT fleet smoothly?
Mike and I are part of the developer relations team here at Golioth, so we get to try out hardware and firmware and replicate the situations that our customers are going through. And when you have custom hardware like this coming off the production line, onboarding can vary wildly. When we're ready to start, we start at the end of the production line. And we're going to approximate what you might be doing at the end of line for both testing, provisioning, and adding credentials to your device. All right, so I'm going to be programming the firmware that Mike sent me using the NRF Connect for desktop tools, and I'm going to open the programmer here. Next up, I'm going to open up a Thingy91 device and actually unbox it with, it already has a SIM card installed because I've already put one in there that is pre-provisioned and ready to go. When I start this up, I'm going to actually hold the center button and I'm going to turn on the power switch like that. That actually starts it up into MCU boot mode, which actually allows the bootloader to accept a new image once we plug it in.
If you're on the production line, you're probably going to have some kind of fixturing that has a proper programmer and is just going to do this whole thing a lot faster.
Now that we're plugged in, I'm going to select the device in the programmer. I'm going to select Thingy91. We already have loaded up this file here. You say it's firmware update plus AT client MCU boot.hex. It is enabled to work with MCU boot. And you see on the left side here, because of how we started it up, MCU boot is already enabled. Now all we have to do is write.
So you can consider the starter firmware as like your stand-in for your power on self-test. But what we've done is we took the AT client from Nordic and added it to this startup firmware, and that allows us to write our certificates to the key storage right on the modem itself.
You may have seen in the past that Golioth can also work with PSKs or pre-shared keys. That's kind of like a username and password, but anytime you're coming off a production line, you definitely want to use certificates.
Certificates are definitely the most secure way to connect your device to the internet, and Golioth has full support for that. And so today we're going to jump into showing how we generate those certificates and then put them actually onto the devices. Any way that you prefer to use to generate X509 certificates is fine. We're going to use a couple of scripts that are in the Golioth firmware SDK. We use them for our continuous integration testing, but under the hood it's just using OpenSSL. So in this case, we already generated the root certificate, so we're not going to show that because it's been used for all of our devices that we generated so far. But Chris, let's generate the device certificate. And in this case, we use, in the Golioth firmware SDK, it's in scripts/certificates. It's called generate device certificate.sh. We then give it the name of the project from the Golioth console. So we've previously created the project. Followed by the name that we want this device to have. That device name does not need to be in Golioth yet, and we're calling this TFM-000. And then the last is the format. We want this in PEM format, not in DIR format. And so I think if you hit return, that's generated in the device. If we wanted to do it again 10 times like we already have, you would just change the name of the device each time and it would use the same credentials. So here you can see all of our devices. You can also see golioth.crt.pem. That is the Golioth public key that we're going to upload to the Golioth console that's going to allow all of these device credentials to be authenticated.
Let's do that now. So we're going to upload the certificate and the public key. This is self-signed, and it doesn't have to be, but it is in most of our examples. crt.pem. We're ready to go. So this basically tells the cloud how to recognize the certificates that are coming in.
Now your contract manufacturer is going to need the device certificate, the device key, and also the certification authority root certificate. And so we have all those in the directory that Chris had before, and we're just using AT commands to send them to the device. But to make this a little bit easier, I wrote a little Python script that does this for us. So we can, with the device plugged in, we can just write those to the modem key store. So this script is going to go ahead and issue AT commands to shut down the modem. It's going to then go ahead and write the root certificate to the key store. It's going to write the device certificate to the key store and then the device private key to the key store as well. And then it's going to read them all out again. And in this case, we're using what's called a sec tag to indicate where these are being stored. We should now be good. It was red because it didn't find any certificates on the device, but if we power cycle it, it should boot up, turn green, and then connect to the cell tower and ultimately to Golioth.
It's green.
Woohoo! Always green. It will turn blue when it gets a connection to Golioth as well. One of the drawbacks of doing it this way is that you lose the ability to get shell output because you're using it for the AT commands, but you're probably not going to be monitoring through the shell at production anyway. A certificate not only enables device encryption, but it also ties your device to that particular Golioth project. So once your device connects to Golioth with a valid certificate, it will automatically be matched to the Golioth project and a new device ID will be created.
Oh.
Hey, there it is. And prior to this, Golioth had no knowledge of this device at all. It's able to add it, zero-touch provisioning sort of setup due to the device credentials that are on the modem right now.
Once your device is connected to the Golioth cloud with a certificate, you can organize your fleet using cohorts. Cohorts decide which devices get over-the-air updates and which do not.
All right, so all of the devices have the bootstrap firmware on them, and we added certificates on them, and we powered cycled them. So they have all now connected to the cell network and connected to Golioth, and they've appeared in this project. So here you can see 001 through 010. We have 10 devices. And one of the things we did to kind of speed this up is we added 9 of those devices to a cohort. And cohorts are a way to group together devices in order to do firmware updates for them. So Chris, let's go ahead and add device number 10 to the cohort as well. And he's just gone to the cohort and devices, and we can click add devices and then go and select them from your fleet. This, of course, could be done programmatically using our REST API, but for today, we're demonstrating it here. Now the device has credentials. It has the original firmware that was programmed during manufacturing, but how do we get to production firmware? Well, we're going to use an over-the-air update for that, and that's to make sure that the latest and greatest is coming to the device and through a secure connection with Golioth. So we're going to go ahead and create in firmware updates on the left a new package, and we're going to call this package main because that is what the firmware is expecting, and we're going to add a new version to it, and this is version 1.4.0, and it should be called Thingy91 Golioth. Yeah, update. Yep. Thingy91 Golioth certs update. It's right there. It's about 5 up from the bottom.
Oh, yeah, I see. Got it. Yeah, I was uploading the original. This is the bootstrap firmware, and this is the actual update.
Yeah, so we're going to open the update. That is version 1.4.0, and then click the upload new version. And now this is staged on our server. We actually haven't rolled it out as a deployment yet. So what we need to do is go to cohorts on the left and select our cohort. We only have one cohort, but we could have many if we wanted. And then we're going to create a new deployment, and we're going to base it on the artifact that we just uploaded. So that's main. It tells us the version that we have, and we can go ahead and start our deployment. All right, and so our deployment has actually now been made available to all our devices, and we can look at the event log to see. So why do OTA off the line like this? Well, one of the things that you want is the latest firmware with the latest bug fixes, but you could also consider things like localization. Your device might end up in different places, and being able to push an OTA update to it instead of having to decide right at the time of manufacturing enables you to do that. All right, and so now we see device 1, 2, 4, or 8, and 5 have all started downloading those files, and we'll get regular reports as these files download. You can also, on this particular firmware, go to the logs of a device, and you could see the blocks being downloaded one at a time. It will take a couple minutes. I think this is maybe 400K or somewhere around those lines. So it downloads a 1K block sizes at a time, so we see those coming in. The device will then take about 5 seconds to go down for reboot and come up, and we should be able to see all of that in the event log.
We're also going to hear it when these come online.
We're definitely going to hear it when this completes successfully because Chris has some pretty clever firmware in that it plays a little ditty on the PWM buzzer when they reboot. All right, and here in the event log, we can see that some of them are done downloading and have gone into the updating state, which means they're rebooting. Over on the right, you can see the current version they're running is 1.0.0, and they're upgrading to 1.4.0. Looks like all the devices.
Yeah. So I guess we can go to our device view as well, and we could see the latest. Not been updated here. Let's try reloading here. There we go.
There they go.
All up to date. So our fleet is now ready to go. That was right off the production line. Now that you've downloaded a fresh firmware image using over-the-air updates, you can go and exercise it just like our other Thingy91 demos. And you can see that all on our blog on a regular basis. This does things like taking temperature, pressure, all of the sensors that are on the Thingy91, and it also outputs sounds, and you can turn lights on and off.
We hope this is giving you some visibility into some of the challenges you may face when it comes time for production. We showed bootstrapping firmware, adding certificates to the device, connecting to the cloud, and downloading an over-the-air update. With the links below, you can go and try Golioth for yourself.